Okay, welcome back. This is going to be our next kinematics example in one dimension. Okay, and this is from the textbook as well, 2.15. Okay, so we want to know what happens if on the same cliff that we were just talking about, the rock gets thrown straight down instead of up. Okay, we want to calculate the velocity. Want to calculate the velocity of the rock when it's 5.1 meters below the starting point. Okay, so below the starting point again, and it has been thrown downward at an initial speed of 13.0. So this time we have our cliff, okay, and this is our starting point, or I'm sorry, this is our starting point, y 0 equals 0, okay, with an initial speed v naught equals 13.0 meters per second. Okay, and we want to calculate the velocity. So velocity, we are going to use what we did above. Let's see, that's going to be v squared equals v naught squared minus 2g delta y. Okay, remember our g is going to be 9.80 meters per second squared. Okay. All right. So we want, we're looking at our rock when it is 5.1 meters below the starting point. Again, our starting point is 0 here, and we're looking at it when it hits, say about there at y equals 5.1 meters. So remember that we will need to insert this negative because it's below our starting position, 0. Okay, so we'll need to plug in our values as 13.0 meters per second squared here, minus 2 times 9.80 meters per second squared, times our delta y, and again our initial is 0 and our final is negative 5.1. So our final is first negative 5.1 meters minus 0 meters. Okay, so that just crosses out. And we get 169 again, 0.0 meters squared second squared minus, using our calculators, we get a positive because a negative times a negative is a positive, 99.96 meters squared per second squared. Okay, add those two values together, we get 268. Whoops, it's getting a little messy here. 268.96. Okay, meters squared per second squared. And again, remember this is our velocity squared, so we'll have to take a square root of both sides. Okay, so our velocity then is going to be positive or negative 16.4 meters per second. Now we need to figure out which value. Is it going to be the positive value or the negative value? Okay, again, we want to look at our diagram here. And because our velocity is going to now be in the negative y direction, I'm sorry, our displacement is in the negative y direction, okay? So that is telling me that our velocity will also be negative, okay? So our velocity then is negative 16.4 meters per second, okay? All right. So that one was pretty short, so I can move on to the final one we have here. So this is another problem in your textbook, or example 2.16. Okay, and based on this data here of a ball falling from a person's hand, we want to calculate the acceleration. Okay, so in the textbook, it has a lot of text, I guess you could say, a lot of words to say, oh, you know, a lot of background, blah, blah, blah. And then it has like a crazy way of calculating the acceleration. But really, it can be as simple as what I'm about to show you. Okay, so I have all of this data, but really, I can just use my first two data points. Okay, so I want to know my acceleration. So my unknown is acceleration. My known is y. Y naught. I have y final as well. I have v naught and v final. And I also have t naught and t final. Okay, so I have all of these knowns and one unknown. Okay, I am going to go back to my PowerPoint and look at which one I could use here. Okay, I want to know A, so I have to make sure that, actually I'm going to go back to this one here. There we go. Okay, because it still has my A in here. Okay, so I need to know A. I have my y naught and y. Okay, so I have my delta x or my delta y. I have my v naught and v. Okay, and I have my t naught and t. Okay, so I am going to use this middle equation, equation 2, to do this. Okay, so I'm going to say, whoops, get my pen, delta y equals, I'm going to look at that again, v naught t plus a t squared 1/2. Just kind of squish that in there. Okay, so then I'm going to, I can do this a couple of ways. So first way is I can plug all of my numbers in and then solve for A, or I can solve for A algebraically and then plug all my numbers in. And that's the way I prefer to do it. So that's what I will show you. I'm going to solve for A. So I have 1/2 at squared equals delta y minus v naught t. Okay, then I have A equals delta y minus v naught t, all that times 2, and divided by t squared. Okay, now looking at my values here, hopefully you can read them. I see my initial values for everything is 0. Okay, so my first thing is going to be, okay, my v naught is 0, so that crosses out automatically. My delta y, remember my delta y is y minus y initial, and if my initial is 0, then there you go. You can just plug that in. So I'm going to rewrite this as a equals 2y over t squared. Okay? All right, so then I want to plug my numbers in. So 2 times y, and my y is going to be negative 0.049. Okay, divided by t squared. My t is 0.1 seconds. 0.1 seconds squared. I'm going to plug that into a calculator. 2 times 0.049. I get 0.098, and 0.1 squared, 0.01. Plug that into a calculator, and I get negative 9.80 meters per second squared. Oh, I missed all my units, didn't I? Look at that. Come on. Doesn't want to move it to the pen. Okay. Meters second squared. There we go. So now I just solve for my acceleration, just using a couple of points on this, based on this data. Okay. And this is my acceleration, oops. This is my acceleration due to gravity. Okay. So we just solve gravity. So basically we're heroes. Okay. Okay. Anyway, that's all the examples that I have for you right now. It should be good. I will be uploading these and probably making a short clip on lab and uploading that one as well. That one shouldn't be too bad. But anyway, if you guys have any questions, let me know. I'm available, and you can email me. You can ask questions on the announcements, anything like that. You can message me on Canvas, whichever works for you. Okay? All right. Have a good week.